So let's give it a try. But rather than me just solve a bunch of problems, I want to help your thinking to develop. So can we try that one with the people nearby? Draw a rectangle, a tennis court, like that. Is that good? All right, so the distance around is 228 feet. The length is 6 more than twice the width. Any ideas?
So I started labeling it. It's 2 times plus 6, so it's 2x plus 6.
Okay. Okay, that sounds good. So 2x, or 2x, or either place, I guess. 2x plus 6, like one of the sides is 2x plus 6?
Right, and then the other one would just be x.
Like this one?
Well, I have it the other way around.
Okay, yeah. Either way, yeah. I mean, you're right. It kind of looks, the other one's certainly longer, yeah, but
right.
Yeah, you're right.
And so since the opposite sides are equal,
yeah,
the other side would also be x.
Let me do better. Tennis court is longer than it is wide, huh? So this is like, hey, could we use W and 2W plus 6? I found that if you use letters that are meaningful, it'll just be easier to know what you have in the end. But you're totally right using X. That's really good. And what did you say from there?
So then the opposite side is also the same? And I just added them up because the distance around it would be 228. And I set that equation equal to 228. So in the end, my equation will look like 6x plus 12 equals 228.
Okay, so is this making sense so far? So she's saying if this is the width of the tennis court, and then this is the length, 2W plus 6 on that, right? 6 added to twice W. Is that good, using a variable like that? And then, yeah, the distance around, what do you call that in math, the distance around a shape? Perimeter. The perimeter. But anyway, you don't need to know that name. But yeah, but what it's just like, it's just this, plus this, plus this, plus this. Huh, yeah, that's totally right. Does that make sense there? So then we would write, here, I'm going to run it. Let me get this one out of the way here. We would write 2W plus 6 plus W plus 2W plus 6 plus W equals 228. 228. Is that making sense there? How are we doing so far? Does that make sense? See the equation? That's the equation you got, right? So it makes sense what Maritza came up with there? Just adding up those 4 sides to go all the way around the tennis court. Do y'all like tennis? Sorry, tennis was my favorite sport. I played it in high school. I was just this morning, I was talking with my wife about why we didn't go to, what's it called? The desert tournament. It was just the Palm Springs tournament. Anyway, it was just a current comment. And I told my kids, like, Dad, yeah, you never take us anyway. Let's buy tickets next year to go see. Anyway, so I'm just telling you my little family stories. I would love to go see some of those pros live. Anyway, so add up those 4 sides. It's equal to 228. Equal to 228. So we add those up. It's equal to 228. Now, how do we solve that equation for W?
First, I combine like terms.
Yeah, combine like, remember algebra. So we don't do a lot of algebra in here, do we? But every now and then, so here's a little bit. Remember doing like terms from algebra? Just add up the same letters. So 2W, 1W. So 2W, 1W, 2 more W, 1 more W. So what do we got there? 6W. Does that make sense? Remember doing that? From your algebra days, your glorious algebra days. 6 and 6. 12. 228. So I'm just combining like terms. Just added up the W's, added up the numbers. That's what you were saying, right? How do we solve from here?
Subtract 12.
Yeah. Remember, it's an equation. It's a system in balance, right? As long as you do the same thing to both. If 2 things are equal and you treat them the same, they'll still be equal. Right? So if I subtract 12 from both sides, and I'll get 2, 1, 6. And what's the last step to solve for x? W? Divide, right? Because you always do it in the opposite, right? Whenever you're solving, so it's divide there. And we get, I don't know, somebody got that?
36.
36, thank you. So, since I use W, I know what it is right away. It's the width, so the width must be 36. So how do we find the length?
Plug in 36 for the W at the 2W plus X.
Yeah, good, good. So then we just use this. This is the formula for length. So length equals 2W plus 6. So plug in the W. What is W? 36. And what is that? 72 plus 6? 78? 78. So the length is 78, the width is 36. We good there? Questions I can answer on that one? Good? All right. I'm going to move on if you're okay. Strategy did we really use there? Well, couple strategies. Draw a picture and use variables. You don't have to. There's totally other ways to do that problem. But that's what we did in particular. We drew a picture and we used letters, didn't we? We used variables. So I'm just going to be giving you lots of different strategies by which you solve problems. Let's try number 2, the rubber ball. Rubber ball is dropped from a height of 176 feet. Each time it hits the ground, it bounces back 1/2 of its previous height. How far off the ground will the ball be after it's traveled 500 feet? Can a ball bounce all the way back up? Like this one's bouncing up halfway. Here, let me write the facts out. So we drop it from, what is it, 176 feet? So we drop from 176 feet. It always bounces up halfway. It always bounces up halfway. So in other words, if you well, let me just stop right there. Can a ball, if you drop it from 10 feet, can it go all the way back up 10 feet? Is that possible? Is that not possible?
Well, I don't think if you just drop it, no, because it's not going to have enough energy to come back up. You'd have to like throw it down at the ground to have it achieve that, because it doesn't have enough energy to go all the way back up.
That's good physics. You're gonna teach those young people some physics? That's right, that's good. Yeah, if you just drop it, it can't bounce all the way back up because it's got to lose a little bit of energy. Good, I like that. Have you taken a little bit of physics? Maybe not? Maybe so? Do you just feel it? Do you feel the physics in that? You're right on, Cami. If you throw it, then you're giving it some what's called kinetic energy. We're not doing physics here, but I just want to. I like physics. All right. Anyway, yeah, so balls cannot bounce all the way back up. Cannot happen because there's always some loss of energy in a bounce. If it makes noise, it lost energy, and it's not going to come all the way back up. So this ball is bouncing up halfway every time, and then their question is, how long until it's traveled 500 feet? Or no, how far off the ground will it be after travel 500 feet? So how far off the ground when it's traveled 500 feet? So first off, do you understand the question? Like, what are they even saying? What do they mean? How far off the ground when it's traveled 500 feet?
So I think like when it's gone up and down 500 feet total.
Yeah, the travel's the up and the down. Are you getting the hang of that? You know what I mean? It's not going sideways, right? We're just taking that ball and we're just letting go from way, way up high, 176 feet. Comes down, boing, bounces up halfway, boing, boing, lower, lower, lower. But that whole time it's traveling, isn't it? It's traveling down and then up, and then down and then up, and like that. And we want to know, where exactly will it be? How far off the ground when it's traveled 500 feet? It's almost like if you had a video. Can you picture it? A video of somebody dropping this ball off a bridge or something, a really high bridge. And it comes flying down and bounces, and you're recording it on the video, and then you freeze frame right when the ball has traveled a total of 500 feet. And at that instant, how high will the ball be off the ground? Right at that instant. Get the idea of what we're trying to figure out? How are we going to do that? Any ideas? I mean, like, what are we going to do to figure that out?
Isn't halfway divided by 2?
Yeah, halfway is divided by 2. Good. So what should we do? 576 by 2? It's a good place to start. So 176 divided by 2 is...
88.
Is that what it is? Thank you. 88. Okay. Then what? What do you think?
Don't you have to add another 88 for the distance it bounces back down? Because it bounced 88 up, and it has to go 88 down.
Ah, should we add another 88? Just 88 plus 88?
And then wouldn't you also add the 176 because that's how far it traveled down, or is it only counting travel after it hits the ground the first time?
No, there seems like there's no limitations. They're counting all travel, it seems like, yeah.
So then you would take those two 88s and add 176 to it as well.
Is-
The purpose travel.
Is everybody seeing in their mind's eye what's happening? What? So what I would suggest, this is great. Your guys' reasoning is great. But I would draw a picture of this. I think that'll really help. Everything you're concluding is right because you're picturing it very well in your mind. It would be helpful. I'd encourage kids as well. A lot of it, I don't know what you found, but I found over my years of teaching and including, we homeschooled our kids, just this resistance to wanting to write something down. They just want to sit there and figure the whole thing in their head, and they can't. They're cocky. They can't really do all that in their head. So to get them to write something, so just encourage you when you teach, get people to write. So I would encourage you to just have them write. So start with the ball here. It's going to travel down. How far will it go down first time? 176, and then boing, it's going to bounce up. 88. And then what's it going to do right away?
Back down 88.
Back down 88, huh? So I'm keeping track, and then over here on the side maybe, I could just keep track of the total distance traveled. So a couple things I'm showing. You want to be really organized, and you want to have a picture. Most problems you want to have a picture, or most of these. That picture is really helpful. Makes things a lot easier. So if you add that up, I don't know, 22. You got it all right, 24, 25, 352? So far, right here, the ball has traveled 352 feet. I just added, the 176, the 88, and the 88. Right, the ball went down, bounced up 88, half, and then went back down 88. That's 52. 352 feet. At that moment, when it hits the ground again, it has traveled 352 feet. We're looking to freeze frame when it hits 500 feet. So what are we going to do next? What's the ball do next? Yeah, how far is it going to go up?
44.
Yeah, half again. So half of 88. 44, and then down 44, huh? So I'm going to add 44 and 44. 440. It's traveled 440 feet. So let me write that in there. At that moment, it's traveled 440 feet. We're looking for the magic 500 moment. So we keep going. What's it going to do now?
22.
Yeah, it's going to go up and down. 22, 22. So add 22, add 22. Is that 484? We're getting close. So it's traveled 484 feet. When it comes down from the up, down 22, what comes next?
Up 11.
Up 11. So it's going to go up 11 and down 11, but that's going to be too much, huh? 11 and 11 is going to be too much. So I better freeze frame at the first 11.
495.
Or just right after. What is it? 495? Let me try to do that a little neater there. So add 11 there. And I get 495. So at the top of its 11 arc, it's traveled 495 feet. And so what will it do then? Yeah, let me do like a blow up of this. So bring it here. Here's the ground. The ball has gone up 11 feet. It's right there. And then it starts coming down. At that moment, when it's right at the top, it has traveled 495 feet. And it's going to start dropping. And remember, we're going to freeze frame the minute it hits 500.
Yeah, 6 feet.
So yeah, how many more feet does it have to go down?
5.
5 more. So if you're up here at 11 feet high, and you come down 5 feet, let me do a little better job on that. Come down 5 feet. So if this is 5, how many feet above the ground are you when you stop? 6 feet above the ground, huh? And that's their question. How many feet off the ground is it when it stops? The answer is, it must be 6 feet off the ground at the moment it hits 500 feet of travel. So definitely need a diagram on that one, right? That's an exercise in carefully drawing a diagram. We good on that? Questions on that one? So we got a giant outdoor circle, has numbers all around it, starting at 1, 2, 3, etc. If the number 3 is directly across the circle from the number 15, how many numbers are around the circle? Hint, draw a picture. So that's like a cakewalk. Do you guys know what a cakewalk is? Have you heard of that saying? When they say something, that's like a cakewalk. What do they mean? What does that saying imply? It's easy, right? That team was a cakewalk. Sports players will say that. And what is a cakewalk? Have you ever been in a cakewalk? What do you do in a cakewalk?
You walk around and get a cake.
Yeah, right, literally, huh? They usually play music, and the people walk around the circle, and then they stop the music, and everybody's standing on a number, have a bunch of numbers around a circle, and then they draw a number like bingo out of the hat, and if you're standing on the right number, they hand you a cake. They got a bunch of people that donated cakes or bought cakes or whatever. In other words, it's easy to get a cake. You just walk around a circle, do the music, and you get a free cake. That's why they're saying it's like a cakewalk. So that's what we're talking about here. So picture a big circle with numbers around it, like a big cakewalk. And if the number 3 is directly across the circle from the number 15, how many numbers are around this circle? So let me let you draw. So 3 is directly across from 15. How many numbers in the circle? Okay. Oops. Try again. I think my thing will do a circle. Maybe. Yeah, hey, there we go. Look at that. Looks professional. Okay. So, all right. So, we got a circle, and 3 is directly across from 15. Isn't that what they're saying? 3 is directly across from 15. You got that right? Yeah, 3 is directly across from 15. So directly across, those words mean something, don't they? So if I fill in between, and we can do that, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't know if I did that totally evenly, but whatever. So I just filled in the other side. And then however many numbers are down there in the blue, doesn't have to be the same amount on the top. Isn't that what directly across means in a circle? If you're directly across, same amount each side, you split the circle. Right? Now, there's a couple of ways to figure out. Let me give you, so a lot of people do a good job to here. A lot of people figure that out on a test set. I've seen many times over the years. A lot of people do a good job. They'll get to here. This will be great. And they'll go, okay, now how am I going to figure out same amount on the other side? How am I going to figure them out? And they'll do something like 15 minus 3. It's got to be 12. Right? You know, 15 take away 3. There's 12 numbers here, right? 15 minus 3. 12 numbers. And so then they'll put 12 numbers up there. You want to be a little more careful than that. Pretend that it really matters to you. If your life depended on it, you're on there, or if you're on a game show, and it's, for all the money, for $100,000, how many numbers are there down here in the blue? Well, you wouldn't just quickly go, 15 minus 3, 12. Buzz it in, 12, right? Would you? I mean, if you had like time to think and and do anything you wanted, wouldn't you do something super careful? I know I would. If my test grade depended on it, I would do something super careful. So 15 minus 3 is 12? Yeah, kinda. But how about I just count them? There's 1, number 2, numbers 3, numbers 4, numbers. So now there's different ways to do it. You could count just the blue ones. You can count the green and the blue, and then not use that when you do the other side. There's not one right way. There's all kinds of ways. Do whatever you want, but whatever you do, just do it real careful. So I'm going to count just the blue ones, I think. So there's actually 11 blue numbers. Why when we take 15 minus 3 do we get 12? Well, because that's counting one of those two numbers. Do you know what I mean? Like, are you tracking with me on that? So anyway, what you could do, you could count one of those two numbers. If when you do the other numbers, you do that as well. Whatever, just do the same thing. So so that means outside, not counting this number and this number, there's 11 numbers. Not counting the 3 and the 15, huh? So that means there's got to be, same amount, 11 numbers up here. So I could go, there's a 2 and a 1 for sure. So how many other numbers are there now? So there's 11, so I've used 2 of them, so there's 9 more, huh? So 16, 17, 18, 19, I don't even know where we're at. There's 1, 2, 3, 4, 5, 6, 7, 8, 24, 9. This is the 10th number, the 11th number. That's got to be it. There's got to be 24 total numbers. Do you see how I came up with that? There's 11 numbers down here, not counting the 3 and the 15. And there's got to be 11 numbers up here. And it's got to be 2 and 1. So for the 11 numbers, it must go up to 24. Or actually, somebody else said something good that I never thought of before. I think it was Lauren. That was a good idea. Instead of doing all that work, once I knew this was 11 numbers, I could just say, look, there's 11 numbers here. There's 11 numbers up there. And there's 2 in the middle. That was a nice observation, I thought. And just add that up. There's got to be 24 numbers. Done. You don't even need to do my little writing it all out thing, huh? That make sense? Or was that Lauren? I think it was Lauren, right? It was Lauren said that? Yeah. I want to give credit wrongly. I think it was, yeah. So it was 11 numbers down here, right? Because once I realized there's 11 numbers down here, well, 11, 11, and 2. 11 and 2, got to be 24 numbers. If you don't want to take the time to even write up the top, you just do that quicker. Got to be 24 numbers. Is that good? Does that make sense? It's all about the diagram, huh? So these examples have been all about drawing a good diagram. All right, let's try one more. Number 4. Suppose that on a balance scale, 2 gold coins. Wait, is that the one? Hold on. Times. A dog weighs 30 pounds plus half its weight. How much does the dog weigh? Yeah, this is more like a 4-minute question. We can do this one in 4 minutes. We'll do the rest next time. This is a good question. It's really the same idea as that next one we're about to do. So a dog weighs 30 pounds. A dog weighs 30 pounds plus half its weight. How much does the dog weigh? Here, how about rather than 45 is an intuitive answer, isn't it? I mean, 30 pounds plus half, right? 30 plus half of 30, which is 15, right? 30 plus 15, 45. But hold on. How can we, it sure seems like 45 at first, doesn't it? How can we know, again, you're on Jeopardy or whatever the game show is, you got 10 minutes and they're playing the music, dun, 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 dun. You got 10 minutes for $100,000. Is there a way, and they said, is the answer for, you just got a yes, no buzzer after 10 minutes. Is the answer 45? You want that money. How could you be sure whether it really is 45 or not? Let's just settle that issue first off. Is it 45? How could we know? Really, you don't know? You seem surprised.
That you could do half of 45.
Yeah, couldn't we just read the words? And just, right, we're saying the dog weighs 45 pounds. Does he? Let's fit the words. The dog weighs 30 pounds. Okay, 30 pounds plus, just going with the words there, half his weight. Right? 30 pounds plus half his weight. What did we say we thought he weighed?
45.
45. So wouldn't that be 30 plus half 45? Is that equal to 45? No. The buzzer says no. It can't be 45. Just by reading the words and plugging in the answer, we thought, if the dog is 30 plus half his weight, see, that's the trick, huh? We think of half 30, don't we? But it's half his weight. So if he really weighed 45, we'd be saying he's 30 plus half 45, and that wouldn't come out to be 45. We're out of time, aren't we? All right. I'll let you think about it. We'll talk about it.